Ladies and gentlemen, a warm welcome to today's highly anticipated webinar on maximizing synergy with autonomous agents using RAG and large language models. I am Tanishka, and on the behalf of the Walking Tree Technologies, I extend a heartfelt welcome to each one of you. It is truly a pleasure to have you all being such a distinguished audience joining us today. Before we delve into the exciting agenda that we have lined up, let's take a moment to welcome those who are still joining us. For those who are unfamiliar with our organization, let me provide a brief overview. We at Working Tree Technologies are dedicated to pushing the boundaries of technology-driven innovation. Our forte lies in conceptualizing and implementing state-of-the-art solutions, particularly in the realm of AI and emerging technologies. As a collective of forward-thinking individuals, we are committed to seamless system integration and driving digital transformation initiatives. Today's webinar is a journey to the future, exploring the intersection of autonomous agents, RAG, and large language models. We'll unravel the intricacies of implementation approaches and optimization strategies, discuss dynamic learning and adaptation, and provide a practical implementation roadmap. Throughout the session, we will aim to equip you with the actionable insights and strategies that will empower you to harness the full potential of autonomous agents in conjunction with RAG and large language models. At the end of the webinar, we'll set aside some time to address your questions and insights. Please feel free to submit your queries in the Q&A box during the session. Let's make this an interactive and enriching discussion. Let me introduce our esteemed speakers for today's session. First up, we have Alok Ranjan, co-founder and managing director of Walking Tree Technologies. Alok's visionary leadership sets the stage for today's discussion. In a world driven by technological advancements, Alok's commitment to staying ahead of the industry trends aligns seamlessly with our exploration of leveraging autonomous agents and large language models. Alok's insights are sure to provide a holistic perspective on the potential synergy between visionary leadership and cutting-edge technologies. Next, we have Scott Siebold, the Chief Technology Officer at Walking Tree Technologies. With over 3 decades of experience in engineering enterprise computing systems, Scott's journey mirrors the evolution of technology itself. From product ideation to operation support, he has witnessed transformative power of innovation throughout the software development life cycle. Today, our Chief Technology Officer, Scott, and his wealth of experience positions him perfectly to shed light on the strategic implementation of autonomous agents and large language models with enterprise computing systems. Joining alongside Scott and Alok is Abhilasha Sinha. Abhilasha is Solutions Architect at Walking Tree Technologies. Her extensive experience as an author, speaker, and solutions architect bring a unique perspective to today's topic. Her core strengths in designing and building complex enterprise applications align directly with our exploration of practical implementation roadmaps. Abhilasha's insights promise to bridge the gap between theoretical knowledge and actionable strategies, providing a roadmap for effectively integrating autonomous agents and large language models in real-world applications. Now, as our distinguished speakers take a virtual stage, let's delve into the heart of the webinar. Alok, Scott, and Abhilasha, the floor is yours to guide us in maximizing synergy with autonomous agents using RAG with large language models.
Thank you.
Thank you, Tanishka. Yep. So as the agenda says, we will go through the introduction to autonomous agents, and we will also take a deep dive into how LLM is kind of empowering these autonomous agents and what are the different benefits of implementing autonomous agent in a business, and then what could be a reference architecture or potential architecture that we can look at, and then eventually Scott will take us towards implementation strategies, as Tanishka said. And then finally, towards the end, Abhilasha will take a little deeper into agent architecture using that. And then finally, she will also wrap it up with a demo of a couple of examples that she has. Can we move to the next slide? So I'll take care of the introduction part. And autonomous agent is something that I have been kind of following for at least the last 4-6 months. And the more I'm spending time around it, the more excited I become. And when I look at the simplified version of definition in my mind, to me, it means that, you know, an autonomous agent is something which in a given context, it brings in the autonomous AI agent, which is a specialized system that operates independently, make decisions, perform actions with minimal or no human guidance, and observe their environment to learn from the experience and additional information. Now, if we look at the different parts here, what you will see is that, of course, these autonomous agents that we are building are specialized for a given purpose. And that's what you will expect an agent to do. They will be expert in given area, right? And in that area, they can help you achieve that in the best possible way. And hence, they should be able to make decisions and perform actions. Now, that's where when I will take you deeper, you will see how LLMs fit in. Now, ideal goal is that we should not have human involvement, but then again, that will stay ideal. We'll keep pushing the boundary, but then goal stays that with minimal human involvement, we should be able to take care of a given task using the agent. And that's what essentially autonomous AI agent that we will be building or we are building is trying to achieve. And the best way to understand an autonomous AI agent will be through an example. And for the example here, we have considered, say, virtual customer assistant. And this is something which is like a very, very prime case for implementing agent, because, you know, we can very easily relate to this. And with any VCA, you would expect that, you know, a system should be able to handle different customer queries. And those queries could be related to anything. It could be related to some problem that the customer may have. It could be related to, asking for some questions, or it could be just related to some concerns that customer has, which they want to express, some experience-related issues that they want to point out. But the deal here is that at the end of the day, customer has some inquiries, some questions. It needs to get recorded in the form of tickets, provide solutions, manage interactions with the customer, and then, of course, based on the past interactions and the knowledge it has, it needs to respond. And then, if needed, it needs to kind of bring in human oversight also into play to be able to do a good job. That's what a virtual customer assistant we will be expecting. Now, if we can further extend that and imagine that, if these assistants are able to learn from the past interactions, the internal updates that we are making in our knowledge base, and based on that, it is able to refine its understanding and improve its performance in real time, or say periodically, that definitely empowers these agents significantly. Now, if these agents are able to make their decision on their own based on the customer inputs during the interactions, as well as past interactions, historical interactions that we had with the customer, as well as the product or say other knowledges that it has, it's able to make decision. And we have mechanism where if it is not able to make a decision, it knows when to escalate to the human being, so that a human expert can pitch in and then solve the problem. And then understanding the context, remembering the context throughout the conversation, and then based on that, staying relevant and making sure that it is able to answer to customers' queries very accurately by always staying within the context. Now, that's another critical aspect, and if we are able to take care of that as well, then of course the agent will be much more powerful. Similarly, there could be situations where the queries that the customer will have, it will be complex. It will be probably multi-part queries where customers has probably multiple questions, multiple problems that they want to state. Now, of course, you cannot go back and tell customer to break their problems into multiple pieces, but then how can we handle that? And if we can handle that using agent, then of course these agents, we can treat them as a powerful agent. And then even the ultimate version of the agent will be that it's able to proactively identify what are the actionable items, and then maybe initiate certain actions. And some of those examples could be, for example, let's say we have a product which has certain failure, and then of course that failure is going to impact certain set of customers. Now, if our agent is able to communicate to all those customers proactively, that of course improves the overall customer experience. Now, if you look at all these things, the autonomous agent or autonomous AI agent promises to achieve all of them. And that's what, I will try to see if we can cover through our explanation during this discussion. And if you have any question later on, we can pick up those as a question. Tanishka? Yep. So autonomous agent promises to achieve all this and even more by truly working as an agent to human experts. So again, when I'm saying agent to human expert, I'm not replacing human entirely here. At least at Walking Tree, when we are building autonomous AI agents, we are treating more or less as a co-pilot. But then again, as I said, like our goal stays to minimize the human involvement as much as possible, so that agents can take most of the decision, agent can finish most of the tasks. So whenever we are building any product, of course, we still leave, in our design, we create a scope for human involvement, but of course, we try to make sure that we reach certain threshold and then only we involve a human being. Can you move to the next slide? Yeah. So in terms of benefits for autonomous agents like VCA, so naturally, we have huge expectations from AI agents, no doubt about that. But then some of the benefits that I can list out here is, of course, this 24/7 availability. Just because it's the AI system available as a machine, you do expect it to work 24/7 or whenever you need. 24/7 basically means whenever you need, it's available, right? Now, naturally, this ensures that your availability is there. Customers will receive services anytime that they need. That improves the overall experience of the customer. Now, apart from that, one of the biggest advantage of agent like VCA is that it provides you the scalability. There are situations where you have a sudden spike in the customer request. Maybe you are launching a new product, or maybe there is a glitch which is impacting several customers. Now all of a sudden you have a spike in your customer support, and then at that time, if you don't have a system like VCA, then you get stuck where you're putting your customers in the queue. That destroys the overall experience, and that's where the scalability is a big help. And other than that, the quality is a big part that the agents play, like consistency in quality, just because, there are lesser human errors involved, and, it is trained and personalized on certain enterprise principles. It ensures that the agents that are built, of course, assumption here is that you have followed the best practices while building the agents, but then it ensures a consistency in quality, and eventually that further improves the overall experience of the customer. Now, if you look at, everything will get related to the customer experience. That's the key thing, to be able to acquire more customer, retain more customer. But then on the left side, you will see personalized experiences. This is something where, of course, as the interactions happen between the customer and the agent, of course, it has knowledge about you as a customer, but then more than that, during the interactions, it also understands, your mood, your emotions, your, say needs better, and then it is able to personalize the responses, personalize the solution, and then get back to you with more appropriate responses. Now that again further adds to the overall experience that, or say improvement in the experience that customer has. And then as I said, like, it can always pick up, human for more challenging roles. And when I'm saying more challenging roles, on one side is freeing up human for more challenging roles, but then from the more challenging roles, you can very well understand that, things that we are not able to predictably handle as part of the agent logic, as part of the building the agents, naturally, that's where human can get involved. And if you look at what are the kind of tasks we are not able to handle very, very easily or nicely, will be some of the more complex things where maybe the LLM's capabilities are still not proven, or maybe some of the things which are more creative, nuanced. It requires, certain things where we don't have access to that. Only a few people have access to that. Of course, in such cases, you would like to, make use of the human, and that's where human in the loop comes into play. That's where human brings in a lot of contribution, and then again further, you can continue using such instances to feed your data back into the system and keep training the agents to make it better. Other big area where I see agents becoming, very useful is change management part. Now, change management is something that, as a technical people, we take it very lightly, but then in businesses, it's very difficult. Most of the businesses find it difficult to implement, specifically the more variables they have, the more touch points they have, it's more difficult to implement. And that's where having an intelligent agent, like, say autonomous AI agents, make it a lot more seamless and easier to implement and adapt to these changes. Naturally, when you are bringing in these new changes, it's easier to train the models. It is a lot more easier to train the model with respect to human being, and it can learn faster as well. And once it learns, of course, as we all know, that there's a lesser possibility of making mistakes, and that's where the change management become a lot more easier. And with that, you can definitely see that, if you are still deciding whether to build an autonomous agent or not, I mean, these are the benefits which are kind of limited benefits. There will always be more benefits, and depending on the use cases, you can relate. For example, we make use of agents for interpreting various documents to convert certain structured information in unstructured information into structured information, and then take care of medical billing kind of solutions. We also make use of agents for our AI platform, which we have called Test Automation Partner. Now, all these different use cases, of course, brings in different benefits, but then this should give you enough inspiration to start thinking in terms of how to make use of autonomous AI agent to solve some of your use cases. can move to the next slide. So what I will do is now is I'll briefly touch upon how LLMs contribute to the agent ecosystem. And as you might have seen by now that when we are talking about ability to make decisions, when we are talking about ability to synthesize tons of information, now that's where LLM is playing a very powerful role, because when you are talking about knowledge, of course LLM is built on say huge knowledge base across domain, across I will say different types of languages, different say in different depth, I will say. But then again, what is more important here is that using billions of parameters, using trillions of terabytes of data, you have an LLM which is very advanced in terms of natural language understanding, natural language generation, and it has amazing understanding of the context, and that enables LLMs to be able to understand the user intents very accurately. And since it is able to understand the user intents accurately, it becomes a lot more easier to break those intents into actionable tasks, or say list of actionable tasks. And that's where the decision making part comes into play. That's where you see that these LLMs are able to make decisions. And on one side you have foundational models fine-tuned for certain tasks and then take care of certain decision making. On the other side, it also allows you the ability to further fine-tune and then make use of those fine-tune ability to be able to do even more specific tasks. Now, if you look at these things, further allows LLMs to be able to extract relevant information, creatively handle any ambiguity in the languages, and overall, again, have a better ability to be able to understand what the user wants and how to interpret that and how to convert that into meaningful tasks. As I said earlier, of course, it has got cross-domain expertise and knowledge integration with wide variety of sources. So that definitely augments, but then as we can continue falling back on context awareness, that's where, even though it has a vast knowledge, eventually based on the context that you supply, it drills down to a level where it stays meaningful for you and for your use case and your problem statement. Now, personalization and customization is another area where it understands the intent, it understands the emotion, it understands as a user what you are looking for, and again you can provide further context to it, and then it finds it easier to personalize details for you. Of course, you still have to provide the right context, you still have to take care of the conversational aspect around that, but then the personalization become a lot more easier with LLM. And then customization is something, of course, you can do through several mechanisms, be it like few short learning, be it through external augmentation, or say even fine tuning, but then it allows you to customize for your specific use case so that you can be more accurate there. Now, in addition to all these capabilities, obviously it provides you multilingual support. At least many of the LLMs provide you multilingual support, and if your use cases are falling into multilingual use cases where you have customers speaking different languages, these capabilities become very, very important as well. Recently, a few months ago, you have availability of multimodal capabilities that something like even ChatGPT provides. Of course, earlier you had GPT-4, DALL-Es, all these things separately. You could have built these capability by using these APIs separately, but now something like ChatGPT provides you multimodal capabilities inbuilt. And then I think what's the most important thing, according to me, is apart from these technical capabilities, the ethical and responsible decision making is something which is kind of integral parts of many of these responsible LLM providers. For example, OpenAI or say even other providers, they vocally claim about following the ethical practices. Now we can always debate about such things because there is no well-defined objective criteria on which you can tick and say that everything is qualified there. But then you can very well trust some of these providers for the job that they are doing, of course, until they disappoint us. So these are some of the things that LLM brings in off the shelf. Now, when you are building agents, of course, you want to be responsible. You want to make sure that your agents are ethical, it's responsible in terms of decision making. And then, of course, you have other capabilities that will improve your overall accuracy of the model that you are building, or say solutions that you are building. Can we move to the next slide? So when we look at the considerations that we need to make when we are designing an agent like VCA, broadly, if you look at, you can divide the overall design into 4 broader categories. One is, of course, the language proficiency, and basically, if you can further generalize it, you can say LLM capabilities. But then, as we discussed, right? So natural language understanding and contextually appropriate response generation. I mean, these things are kind of, we are taking as a granted expectation that we need to have this to be able to do a good job as an autonomous AI agent. Otherwise, it becomes a lot more rule driven and a lot more difficult to kind of cater to larger needs. But then apart from that, of course, when we are talking about agent, we need to have a certain conversational aspect considered and implemented. And that's where, whatever agent, providers you will see, frameworks you will see, they bring in this conversational context management quite well there. Of course, by default, the LLMs will not provide you, say conversational or say memory part, but then whenever you're building anything, you need to choose framework which has got a good, say, design for conversation context with coherent and continuous interactions, so that you can interact better over a period. Now, it's not just the one agent talking internally and over a period. When we are talking about agents, of course, there are agents which could have multi-agent communication. You can have multiple agents talking to each other and then solving more complex problems. Now, in such cases, managing the conversation across the agent becomes even more tricky. So you need to definitely understand those contexts, understand how the conversation has to happen among the say agents and within the agents. Now, the other thing is, when we are talking about something like customer assistant, a virtual customer assistant, of course, in that case, even the communication style become very important. And most of the cases, these agents that you will be creating will be for a given brand, for a given company. They have their own way of communicating or addressing the client. Their clients are kind of used to certain way of communicating with the agents. So now, of course, you need to be aware of those things. You need to design accordingly to make sure that we are able to take care of the brand's values and the overall customer engagement ethos. And naturally, the multilingual part is something that we should be definitely taking care of if there is a need for that. But given that these things will be and can be nicely taken care by, say, some of the LLMs that we are generally using, there are more to it when you are designing or when you're considering to put a overall design for the VCA. Okay, so the personalized interaction part and overall user experience part is very critical. And as part of that, definitely you need to make sure that based on the customer's interactions, preferences, etc. You are able to tailor personalized responses to the customers. As I discussed earlier, performing emotions and sentiment analysis to make sure that we recognize and respond to customers more appropriately by respecting their mood and challenges and frustrations, excitement, and then we eventually enhance their experience rather than we just say monotonous and then they disappoint the customers. And at the end of the day, be it any system that you're building, whether it's autonomous AI agent or just any application, it has to be intuitive, user-friendly, and accessible. Now, of course, when you are involving, say, autonomous AI agent, when you are involving LLMs, the way LLM takes input, the way LLM responds to those inputs are slightly different compared to the traditional programming or say traditional functionality that software provides. Now, of course, you need to understand these things. You need to factor all these things in your design and then have a good user experience design there. And then assuming that you have taken care of language proficiency, user experience, of course, next big question that people have is it secure? Is it scalable, right? And as part of this security part, of course, since sensitive data is involved, so data protection and securing the data so that only the authorized user have access to the intended data, it becomes very, very crucial. Specifically, whenever you have personally identifiable information involved or any customer information involved for that matter, it's very important that we strictly adhere to the industry specific guidelines and then make sure that we follow the given rules, general rules as well. Now, that's a basic thing that we have to take care. Doesn't matter how good software we are building, how powerful agents we have built, if this is not taken care very well, then eventually we'll be sitting down and we'll be inviting unnecessary legal challenges. But apart from that, I think what is more important as well is that whenever you have high volume of interactions, you're still able to kind of take care of them. Now, this is one area where you have some challenges. For example, of course, on the application part, you have some control. You can bring in elasticity. You can bring in scalability by controlling the cloud that you are hosting in. But then if you have the proprietary LLM tools like for example OpenAI, now naturally when the volume is very high and it's not just specific to your use cases, if in general OpenAI has used volume, many times we have seen them struggle. Now this is where as a agent developer, you need to be able to think that what are the strategies that you can bring in to take care of your customer experiences, as well as maybe do you want to probably have some fallback mechanism? Do you want to maybe consider similar models which can be your fallback option if your primary model is not helping you achieve the goal and maybe there's a performance issue? Because there are certain things which are definitely in your control. There are certain things which you will be depending on somebody else like OpenAI. Now, this is where, again, the design consideration has to take care of the scalability part. And when it comes to integration with the existing system, of course, whether you're building any agent or say any conversational application for the enterprises, you will be required to be able to integrate with enterprise resources. But the great thing is that with the support from LLM, where you can have something like text to SQL, you can have text to APIs. I mean, these integrations have become a lot more seamless, and you can very well integrate that with your documents. It can interpret those documents, build knowledge base out of that, and then work with that. You can very well integrate that with certain knowledge that you may have in your vector database. So the real here is that integrating with your enterprise resources are becoming a lot more seamless now, but then again, still it needs to be factored well. You still have to have right level of roles and access considered so that right agent has access to the right information. And again, I mean, if you look at tools like Autogen, I mean, it provides you that capability where you can control access at the agent level. You can have configurations which allows you to kind of be very specific, and that's how you can definitely make sure that you have the right level of control. But then again, these design considerations you will have to bring in to make sure that you have the right agent design. And finally, any AI system that you are building, it has to be reliable, it has to be explainable, then only users will be able to trust and utilize it in a long term or maybe in a sustainable way. And in order to do that, while the ethical considerations and making sure that you are following all the legal best practices or say industry guidelines, those things are definitely important. But then apart from that, you do need to think of incorporating feedback loop for making sure that the experts are able to give feedback, you are able to incorporate those feedback, and the system continues to keep improving through those feedback mechanisms. As we discussed earlier, we do need to have robust error handling mechanism, and whenever the agent is not able to handle a given scenarios or given intentions, or even say for example, if it is not able to understand intention itself, then it should have a way to fall back on the expert human being so that they can pitch in and help. And overall, of course, when we are doing all these things, we should have continuous monitoring and analytic system in place, which is kind of giving us continuous analysis in terms of how we can improve further. Now, if we can bring in these considerations, then we'll be definitely able to design more powerful and meaningful agents like we see. Tanishka? So this is one architecture. I'm sure if some of you are spending time around generative AI, specifically ASIA is, if you are interested in, you might have come across this, but then this is something which I definitely appreciate a lot, and I feel that some of the implementations that people have around agents, it kind of tries to mimic an architecture like this. So I thought I'll quickly run you through this so that you can relate to how a single agent works. Of course, you can generalize it, you can further generalize it to see how the multi-agent system can work, but then at least in case of one agent, this should give you a fair idea about how it operates end to end. And when you look at as a user, when you're interacting with an agent, of course you go with an objective. You always have an intent that you want to kind of express, and you expect the agent to help you solve that problem, or say maybe respond to you with certain queries, etc. But at the end of the day, those intents will get converted into a set of tasks for the agent, for the AI agent. Now, there will always be the first task that the agent need to pick up and execute that. And that's what you are taking to the current state of the whole execution system, wherein you pick up the current task, the top task, the first task that you have, and then you start executing that. Of course, before that, your system, your LLM system kind of identified the intent, it identified the possible tasks to solve that intent, and which one is the first task. So there is a certain level of prioritization that has happened, and that's when you execute your task. And when the execution engine starts, then naturally, of course, it will, with certain iterations and all, it will finish. it will return the result, and this result is something which you pass it on to the task generator. Now, while you pass these results to the task generator, what you also do is for every execution and outcome of that, you continue storing them into a memory, because when you are working over a context, or when you are having a conversation, when you are working together over a larger, say collaboration, you need to have that memory to be able to go back and have the right conversation, have the right context available to you. So now, apart from the task result that you have, you always refer to the memory, the context in which you want to pick up the result, and then identify, do I have more tasks that I need to take care of? Do I need to generate more tasks? And that's where the task generator start generating more tasks. Now, when it goes back, of course, it reviews that I already had a list of tasks, I have generated more tasks, make sure that it doesn't overlap with each other, it doesn't conflict with the existing list of tasks. So you go and have these new tasks added to the task list, take care of that it's not overlapping. And then naturally the next step is that what's the next task that I want to execute. Now, as a real agent also, if you look at, that's how you will typically prioritize. That's how you would like to do. Now, in this whole process, of course, this whole thing has to be executed in a secured manner. So there has to be certain way to make sure that at every step that we are transitioning, we should have a security mechanism to ensure that we are not violating any compliances, any rules, any ethical issues. And that's where you can have a security agent reviewing each of these executions. Now, if you look at, in nutshell, you have tasks, you have execution, returning outcome. Every time you have outcome gets saved into the memory, that memory gets fed into a generator, and then generator gives you the new list of tasks. And eventually at some stage, the generator will say that, okay, no more task is needed to be generated. Or maybe you will have some indicator which will say that, okay, now it's the end of the, outcome, it's the end of the execution, just return the outcome, right? And that's where the whole state machine comes to the end. It returns the final outcome to the users. So this should give you an idea about how an agent takes care of an intent of the user. This is the link that you guys can refer. It has got more explanation around it. Tanishka, can we move to the next slide? So with this in place, now that you understand overall how an agent works, how an individual agent works, I will hand it over to Scott to give you guys an overall idea about what should be the implementation strategies for implementing, say, any autonomous AI agent, not necessarily just the virtual customer assistant, but then for that matter, any AI agent. So Scott, over to you.
Okay, thank you, Alok. So yeah, thanks a lot for that. What I want to do now is maybe take a little bit of a step back and look at kind of the overall of how we would go about implementing, what's the thought process, the strategy that you would put in place to even think about using it, what to do with it, and how do you implement it, and that kind of process and thinking through that. And then I'll also cover a little bit about what an agent is and kind of look at it from what I would call a human perspective. So we'll go through that on the next slide. So but let's think about, what is the strategy, for implementing AI? Everyone wants to somehow use AI magically, and even the concept of an agent is awesome, right? And somehow you want to put it in your business and really make things magic and make some magic. Well, there's some things you got to go through to accomplish that, right? So that first one really is the desire, to innovate. So what's the desire for innovation? So this step really represents the initial motivation to improve or to innovate within a business or a technology organization. I know even within our organization, when we're thinking through bringing in different technologies, the first question I have is, why are we doing that? And what's it going to accomplish for our business, right? Technology is always a cool thing for most of us. But for a business, when you're running a business, right, you need to have some goal and purpose in mind. So first is the desire and a real reason for wanting to innovate, right, and wanting to kind of improve your business processes and so on. So the next thing that you would really think through is, well, you need to define those business goals and use cases, right? So it really needs to kind of, the rubber meets the road. What's this going to do for us, right? And this is really a critical step, really, for any organization to define clear objectives and potential applications for AI systems. So what are those systems really going to do for us, right? What does it really mean to us? So defining clear business goals and use cases for AI, and then understand the different LLMs. Certainly we've got, the GPT models out there that ChatGPT utilizes. There are also other LLMs out there as well, right? There's Claude and there's others. There's open LLMs as well. So really discovering and looking at what's out there and understanding what those large language models can really do for you and how you can leverage them. So after you've done those processes, so you got a desire to innovate, you have clearly defined your business goals and use cases, and you've kind of understood the landscape of the large language models. Next, you need to really find a team and assemble a team that's the right mix of skills that you need to have success for the project, right? So form your team with the right skill sets to be able to accomplish that based on your requirements and the LLM that you're going to use. And next, we're going to get into the stage where we're designing the agent, right? So now we're really getting into that technical development for the AI that you're going to use. It's going to include things like, learning algorithms, decision-making processes. So really kind of getting to the nitty-gritty of, hey, let's design what our agent's really going to do, right? What's the thinking process? What do we need to do to train and learn and develop learning algorithms so that it does learn? And then you're going to have to start looking at that point at infrastructure and your data preparation, right? So there's going to be, it's not just magic. We wish it was, right? But it's not. So you really have to start looking at what your infrastructure setup is going to be. Preparing the data sets, right? So that's a huge one. Lots of data out there, even internally, right? So it's one thing to lean on a pre-trained model, right? But that's a certain amount of data. Then you've got your data that maybe is going to augment that, and then you're going to customize that LLM. So you've got to start thinking through what data sets you need to prepare. So really kind of drilling down into what we have to do to implement the solution. And then next, you're going to get into the stage of developing and customizing. So it's really adapting the AI system to meet specific needs and specific business cases, right? So this is the point where you would do that. So you're actually getting into the development of the AI to meet those business needs. And then, we're not going to be able to operate in a vacuum with this, right? LLMs and these pre-trained models have lots of information out there, but eventually, it doesn't always know and probably doesn't know anything about your business, right? And the systems that you integrate in with your systems and then other systems that you're integrating in with. So you're going to have to now consider that, right? How do you integrate that? And how do you make it all work seamlessly within your current business systems and processes for that matter. And then the next phase, and a really very important phase, right, is when you get everything developed, it's set up, it's developed. Now you're going to want to go through and really do rigorous testing to validate that the AI's performance and its accuracy are kind of measuring up. You're going to need to test it with different scenarios. So really doing rigorous testing and validation to make sure that the agent's really doing what you need it to do. And I almost liken this to For example, when we're bringing on a new developer, we need to make sure that that developer understands what they're working on, right? And that they're really ready to get out there and what I would say, put into the wild, right? So actually put onto a project and ready to go. So that's kind of what you're doing here. You're really testing this and you're validating what it knows, the accuracy in performance in different scenarios. And then you go into the deployment stage where you're actually rolling it out now, right? So you've done all this testing. Now you're actually going to roll it out into your system so that it can be used, right? So there's thought processes that need to be done around that. How do we deploy? So maybe now we have to start looking at just like in a normal software development world, we have DevOps programs, right? So now maybe we need to develop an LLM ops operation so that we have a good way to manage and deploy the AI system, right? So, and then once it's out there, like anything else, we need to do ongoing maintenance, do improvements. So really regular updates when things need to be updated, or maybe there's maintenance that needs to be done. Maybe need to increase performance and that kind of thing. So it's also just evolving requirements, right? So after you start using the agent, you may start realizing, hey, this is great. Maybe I need to add some more and ask that agent to do some more things. So you're going to have ongoing maintenance and improvements to the system that you need to be thinking about. And how do you integrate that into your overall deployment, the overall deployment and monitoring of that model, right? So you need to be monitoring the model as well, have a way to bring those improvements in, much like we do in a DevOps program, right? Realizing the business value then, right? So it's out there. How do we know that it's working and really giving us what we need? So that kind of comes down to, hey, how do you recognize or realize business value in it? So you got to have a way to measure it. You got to know those business objectives. Back when we looked at those business goals and use cases, you need to be thinking about those objectives and how do you measure those objectives and that they're clearly being realized in the system, right? So maybe you need to do something to, maybe you had a case where you just wanted to improve efficiency, right? Maybe it's reducing cost or enhancing customer experience. So you need to have a way that you're really going to realize the business value. Nishka, next slide. All right, thank you. So just again, like I said, we're going to take a step back, and this is kind of where like the title says, LLM-powered autonomous agent system. Well, really, what is that, right? And when I do anything, I have to really understand what it does before I can fully grasp. And this picture kind of does that for me. In that if we look at this, we've got this agent out there, right? And then we've got all these different things, and you see these blocks, and I'll kind of walk through these blocks. And the way I'll approach this is kind of talk about, what's the interactions and why for each of them. And it kind of starts right with an agent. And I don't know, maybe I'm just too much of a techie. I think back, when we used to talk about CPUs, right? The central processing unit. This is the brain, right? So this is probably the LLM itself. It's responsible for understanding inputs, for generating responses, deciding, which tools to use and when. So that interaction with the agent, it's going to interact with all the components, and it's going to direct tasks to the appropriate tools, for instance, or it's going to do the storing and retrieving information from memory and plan actions and actually carry out the actions. And then if we look at this, and Alok's already kind of alluded to this, right? One thing that's very critical here in this process is maybe you need to do certain things, right? Maybe you need certain tools that you need to access. Maybe it's, maybe it's a calendar. Maybe it's a calculator that you need to use. Maybe it needs to go out and execute some snippet of code somewhere. Maybe it needs to do an internet search, for instance, or maybe it needs to use RAG to be able to access something that you've got out there in a data store of your own, and it's going to augment its actual model is going to augment that with your data. So these tools and these different tools, and this is just a few we've listed out here, but these are different tools that you might need to accomplish your task. Just like, you or I, or an agent, whatever that agent might be, is sitting there and saying, hey, okay, I need to look at my calendar. I need to calculate something. I need to use a calculator, or maybe I need to go look up something and search. Maybe I need to use Google, right? And I need to Google something, or maybe I need to retrieve something from my own system to augment maybe a letter that I'm writing for someone. So that kind of thing, various tools. And this kind of paradigm here with an autonomous agent allows us to interact with those different tools to augment what the agent is able to do. And then in terms of memory, and I like this concept because I can sort of relate, because we have memory ourselves, right? We have short-term and long-term memory. So when we look at this and we look at the interaction with the agent, the agent's going to interact with that memory to do different things, right? So when we think about short-term memory, even in our day-to-day lives, maybe we need to know, right? We need to understand the context of what we're currently working on, right? So we're using short-term memory to say, okay, and sometimes I'm not great at this. So I have to sit back, and because I get distracted, and it's like, wait, what was I working on? Short-term memory, right, allows the system to remember the context of what it's even working with. And then you've got the long-term memory storage. So when it's doing these actions, it's looking things up, it's doing the planning and actually, implementing the actions. It needs to kind of remember, what have I done, right? And that's where the long-term storage comes in. It's like, hey, I remember that. I've done this. Let me go look that up. Yep, I've done that. Got it. Let me pull it from long-term memory and realize that, hey, I've done this before, so I can use that information to carry out some other action. And then as we look through this block and you start looking on that right-hand side and looking at planning, right? Just like you or I would plan. This component in the agent system is where we're actually doing the strategizing, right? Or we're determining the sequence of actions or responses that need to happen. So, and in this, an agent uses planning to decide, the best course of action based on the current context or objectives, which that involves, like setting goals or predicting outcomes, managing tasks, those different things. And why would we do that, right? Well, planning is essential for goal-oriented tasks or complex problem solving, or allowing the agent to navigate towards some desired outcome, right? And then as we look at and I'll go through these others in just a sec. I want to get to the action part of this quickly. The action is really the output of the system, right? Which could be a number of different things. It could be sending an email. It could be performing a calculation for doing something. So a number of different things, number of different actions could be there. And the actions really are the result of that planning process and the use of the tools that are executed by the agent. And this is important because it's the agent's way of affecting the world and providing outputs to the user, and really kind of completing that interaction loop, right? And just real quickly on the right-hand side, speaking of action, speaking of loops, this is kind of, our brains are kind of a closed loop system. And so is this, and we need it to be. And why is that, right? So we need to learn from things. So when we do things, we learn from things, and hopefully we get better. Kind of the same thing that happens with an agent system, right? So that agent needs to be able to reflect, right? So you need to be able to reflect on what's done and do self-criticism, right? And then, looking at a chain of thoughts and piecing that all together. So the interaction the agent has with all of this is the agent reflects on, say, its performance. It critiques itself to improve. It follows a chain of thoughts for complex reasoning. It can decompose goals and then decompose those into sub goals for easier handling. And this whole thing is the process. These processes are really key for an autonomous agent's adaptability, for its problem solving, and for its continuous learning. Right, so they enable the agent to handle complex tasks more efficiently and really learn from its actions and perform better in future interactions. So with that, really what I want to kind of drive home on this slide is just the way we think about an agent and the different interactions it has and the different components it has. And when you think about it, it's really makes sense in terms of even what a human thinks, right? So that's where the term agent really comes from, is that we're able to do that and interact just like we honestly would do as a human being. So with that, I'm going to turn it over to Abhilasha to kind of talk a little more in detail about the agent architecture. So Abhilasha, I'll turn it over to you.
Thank you, Scott. I hope my screen is visible.
It is.
All right. So we spoke about, we heard about what agents are able to perform, and the different components of the agents. Now we look at from the technical perspective, like how do we implement, or what are the different components of the technical architecture of an agent. If you have to build an agent, what will be the minimalistic view? And that is what is covered in this slide. So basically, the centerpiece of it is the AI agent, which we are talking about. Now, this AI agent would have two main parts to it. One is the implementation, like how we are going to implement it and how we are going to evaluate it, because evaluation is another very important aspect to ensure that the agent is performing the way we expect it to. Also, externally, if we are to improve the context by providing some specific data sources, so this is like any LLM application, you would have seen this high level architecture, but then with respect to agents, some things are specific here. So now with the generic architecture, you have the data pipeline, wherein you will bring in data from different sources. You would have the embedding models, and you may save your embeddings in a vector database so that you can retrieve it from there. So this would create one RAG, one retrieval augmented generation for you, where you can query for a specific content or question, and then you get the most relevant response. And again, so there you can have your own strategies of how you can improve your responses and improve your RAG behavior. But then with respect to AI agent, when I look at the components, so this becomes the first external component. The second thing would be, like, as we are talking about tools, because agent is something which can act based on the different things it has to its disposal. So be it the tools, be it the instructions, be it the memory. So as Scott showed in the previous slide, so one of the external aspects would be the external tools for which we could have APIs or some database access, which we would need to use to perform the action. So we could have like maybe some external systems, some ticketing system, or maybe the calendar, Google Calendar, if you want to update, so the Google Calendar API. So accordingly, the APIs would be used and by the agent. Now, within the agent architecture, you would have the internal tools like the code interpreter, the knowledge retriever. So the few things which are provided as part of the ecosystem, depending on what, like which framework you're using for the implementation. So again, if you see here, there is a good variety of options available here. And then, so you have LangChain. So LangChain provides the agent functionality where you can have, you can define your agents like the React, Reason and Act is one flavor of it. So, and basically you provide instructions through the prompt, and you ensure you're enforcing a behavior to your agent. Your agent can make decisions. Similarly, Llama Index has data agents which can read and write to data sources. So again, there is the factor of decision making, where you have a set of actions which the agent can perform, but on what pretext. So if this happens, then this is the action. If this is what the user is asking for, go look into this document. So there is an understanding which the agent has inbuilt, and that understanding would come through means of the prompt. So prompt is nothing but when we have to say the planning aspect of it. So how do you want the agent to behave? That you would enforce by means of prompt. So you will have a default behavior if you're using an agent of, say, a data agent or a LangChain agent. On top of that, you can add your instructions to add that specificity to your agent to make it work as per your requirements. So that's where then you have OpenAI Assistant, which was recently released, where some models come with this similar capability. There you can attach tools and you can attach your data, you can augment data to your model, and the model can behave like an agent, making decisions and responding. So again, there are other features like you have threads to maintain memory, you have file system. So the assistants will have access to the file system to answer the query or to take the decision of what action to be performed. And lastly, Autogen, so another very powerful framework developed by Microsoft. So Autogen is, I would say, it gives you a more interactive behavior where you can define multiple agents and bring in an environment where they communicate and perform your task. So if with the other frameworks also you can build that, so you can have multiple agents working, but Autogen provides from the framework itself, it provides that high level abstraction, so you can implement the multi-agent behavior where the multiple agents are working in conjunction and responding to your queries or acting based on the requirement. So depending on whichever framework you're choosing, you would have all these different components. So parser could be used to, say, have a control on the output which is getting generated. You can have the memory elements. So again, as Scott mentioned, the short-term memory, which is during the conversation, or something which you want to persist and be used for future conversations. So something where you want to, say, change the behavior of your agent and move it to its permanent memory so that it is referred every time. So that's where the long-term memory comes in. And then you have retriever elements. So that is where you can augment your AI agent capability. And then you can implement using chains where you can have a multiple chain of agents. So if you're using, say, a LangChain or a Llama Index data agent. Similarly, like once you have the implementation done, you need to have a structured way of evaluating your agent behavior. Because definitely, if you're implementing in an enterprise ecosystem, it is like not acceptable to have any kind of deviations in the behavior. And that's where the evaluation block is important, to bring in that control, to bring in the constant evaluation and feedback cycle, have proper scoring mechanisms, have proper ways to evaluate how your model is performing. So for example, if it is a RAG, is it like selecting the right context with respect to the question and giving you a like a relevant answer? So you can have different scores related to relevancy. If you're, say, generating a code, maybe it could be related to code coverage. So depending on the use case, you can define your evaluators, and that's where so I've quoted two of the frameworks. Langsmith, which is part of the LangChain framework, wherein you can define custom string evaluators, where you define the behavior of your evaluator and expect, define what kind of scoring you're expecting. So that brings in the extra control. TrueLens Evals is another framework which gives you like a nice ecosystem. And for RAGs, where you have like a way to, so already existing evaluation metrics are available for measuring the relevance and things like that. So with this in place, you would host your agent on maybe a Streamlit or a LangServe. And of course, at the background, you know that this is powered by the LLM, which could be any of the popular LLMs. And you would make use of a cache to ensure like a efficient response and reuse of the data which is being queried multiple times. So with this architecture, you can have like a optimal implementation of your agent and bring in the flavor of evaluation. So like I would cover a few examples related to Autogen, simply because Autogen provides you the multi-agent behavior and brings some additional capabilities inbuilt in it, so that you can just directly use it by means of some parameters. But of course, you can implement the same in other frameworks by means of some customization, and Autogen brings in that high-level abstraction, so you can easily use it. So the kind of agents you have, the assistant agent, which is supported by your large language model, your user proxy agent, which is a kind of proxy for the user, so you can have a human input here, or you can skip the human input, but you can have the code interpreter as part of the user proxy if you want to say evaluate or validate the code which is getting generated. Then you have this new retriever user proxy, which is actually like Autogen's flavor of RAG, where you can attach the knowledge base to your assistant, and then the assistant will use it to answer the questions. Also, there is another preview version of agent, which is the GPT assistant, which actually makes use of the OpenAI assistant in the background. So you can actually use it in conjunction with that, and maybe bring in the capabilities of the OpenAI assistant, like thread and assistant, creating say the assistant accessing the files, so that you can define as part of the GPT assistant. And then you can have a chat manager wherein you will set up the different, so if generally if you're trying to set up a multi-agent conversation, so the group chat manager will be the like kind of a moderator, which will transition the conversation between the agents interacting with each other. So like to give you a view of, I'll show two examples here. So one is where we are using the GPT assistant in Autogen. So in order to do this, so basically you would have to say you would have to define the file and the assistant. So basically, what we are trying to do here is bring in the RAG flavor. So with your Autogen or with your any assistant, so you bring in the RAG retrieval augmented generation, so that you can limit the context of your model and prevent hallucination. And in any enterprise scenario, you would have your ecosystem, your knowledge base, which you would like to augment your model with. So that is where you can actually create the files first. So this is what this part of the code is, which is provided by the OpenAI assistant. So you can create the files in it, and then you can actually create an assistant, and then you attach the file which you created to the assistant, and then the tool you will specify as retrieval. And of course, another thing to note that this will not work for all models. So there are only specific models which are like for this OpenAI assistant, which are like enabled for retrieval. So this is one of the models, 3.4 Turbo 1106, which you can use, and you can provide the instructions. Now, once you've defined the assistant is attached to the file ID. Then you would like set up the configuration, which, so generally if you're using Autogen, whatever parameters you attach to Autogen, you would provide as a configuration. So that is where we are giving the assistant ID and the file ID. So what this does is, it actually attaches this assistant which you defined to the GPT assistant, which is the Autogen assistant. So it's like bringing in two flavors. One is the OpenAI assistant and augmenting the Autogen with it. So then you define the GPT assistant agent, and here is where you're providing this config. So now this agent is actually powered or equivalent to the powered by the OpenAI assistant, which has access to this file. So it will make use of this file to answer the questions. And then you have the user proxy, which is the one which will like initiate the conversation and ask the questions by means of like this initiate chat function. And then so here we just have two agents, the user proxy and the GPT assistant. They will interact with each other and then give you the response. So I will show you like the response, but I'll just cover the other flavor also here. So now the second one is the retriever user proxy. So this is another like flavor wherein you can attach the document in a slightly different way. So here you're not using the OpenAI assistant. You're directly applying RAG to your Autogen agent using this retriever user. So here, as part of the retrieve config, you would define your details for the document path, or like you can give multiple documents. You can give the token size, which will be used to like take this document, do the chunking, and then put it inside your DB. So here we are using Chroma DB, which is used to persist this document, and then this will be used by this agent to respond to the questions. So this is, and then of course there is no code. So generally, if it's a user proxy, we have the code execution capability. So if you don't need it, we can just set it to false. And then we have a normal user proxy, which is our moderator, who will start the conversation. And then as part of this, so if you don't want a human input, you can say never. Now, as part of this conversation, I have considered two additional agents just to give you the feel of multiple agents interacting with each other and coming up with the answer. But then if, so here again, like this is using the default, like the base config. So it doesn't have the RAG. So if I'm using only these agents, then it will not have access to the data. If I'm using this agent, this will have access to the data. Also, there is a way how I can attach this capability to these simple agents also. So we will look at the code to give you a view of that. So I've executed this. So you will have your dependencies, and then you would, so PyAutogen is like the default dependency, and then there may be like specific dependencies depending on the kind of agent you're using. Now you would, so this is the GPT assistant, the OpenAI assistant version, where you create the assistant with the, so you create the file. But let me show. Yeah, so here you create your file and you create your assistant with the file ID. So this is the file created, and then you have the assistant created using this model, and then you import it into your config list, has the model, and your assistant ID and file ID is used here, and then it is configured. So you have your GPT assistant agent and your user proxy. Now, if your user proxy asks the question, so you can see like your assistant says, I can look into the file to find information about this. So since as part of the instruction, I've given that you are skilled at question answering using the data you have. So that's the reason it is referring to the data and then trying to answer the question. So this question is actually not related to this. So basically this is the insurance policy document which I have used here in order to have the question answering for the agent. So this question is actually a very generic question related to insurance. But since I have forced the agent not to respond without referring to the data, so it's saying I reviewed the file, but I can't find any information specifically about this. In fact, if you just ask GPT this question, it will give you an answer to this because this is a freely available information. Now I'm asking a question related to the Cigna Health Insurance, and that's where you can see that now my model is able to, so it is able to look up and then give the information. So all these details are coming based on the PDF which was provided as the data which is available with our GPT assistant. Similarly, like there are other questions. So what are the reward benefits? So again, you can see that it's saying that I'll start by reviewing the file you upload. So this is the agent actually talking to the user proxy, like how it is approaching. So it is giving like a feeling as though a real person is communicating, the way the agent communicates. So it says that reviewing the file you uploaded to gather information about the reward benefits. And then it goes on to give you the answer. So the take control rewards and the which allow. So this is basically coming from this document, like how the points work and all that. So maybe just to give you a view, this has actually the rewards, which this is talking about. So yeah, I think it's here. Yeah. So take control rewards. So this is what it is referring to and giving the answer. So similarly, now the other flavor, which is the retrieval agent. So let me just quickly show that as well. So the difference here is because this is like a specific type of agent, we have to install this specific library of Autogen with retrieve chat, and then you can go on to define your config list. So this is the normal retrieval. So you can work with your normal models, that is our 3.5 turbo and turbo 16K. So this is using RAG with Autogen, and so you can use any model here for that matter. You can use your Claude models or your Cohere models, so you can use those. And then you can actually, so you can see these models are available. So whatever you provide in the config list, and then you can actually allocate that list to your config so that all your agents will use this config. So this becomes like the default configuration. Now I want to augment it with my document which I have uploaded here. So yeah, I think it's disappeared. But then the idea is that this retrieve user proxy agent is referring to this PDF and then storing it in the ChromaDB, and then it becomes available through this user proxy. Additionally, so this is a configuration of this agent. Now there are other agents also. So just to show you, like if I use these agents, it doesn't actually retrieve the data, it gives a plain answer. Now, and this is the question, like main features of Cigna Health Insurance policy. Now, if you look at this code, if there are two functions defined, one is the RAG chat, where we have included the mod 8. So mod 8 is our moderator assistant, which is actually the retrieve user proxy. And the other no RAG is not using the mod 8. So it is using the other three agents which do not have access to the retriever, the RAG data. So and then there is, so with this we can initiate the chat. So the moderator initiates the chat and gives the response. So and then so I'll come to this in a bit. Now coming to, so yeah, the ChromaDB is installed. Now this is no RAG chat, and this being a generic question. So definitely Cigna health insurance policy has some generic features which are available to ChatGPT without the reference. So it is able to give some generic answer here. Now just see that it is not using chat. It is having the moderator, which is using the insurance agent and then giving the answer. So these, it's not using the mod aid, which has, now if you see the RAG agent, RAG chat, so this will actually show you like, so here the RAG chat is actually setting up the ChromaDB, and then it is, so it is saying, you can see the communication here. So the moderator assistant is the retriever assistant with what we have. So it is a, the retriever augmented coding assistant, or assistant for that matter. It should respond based on your own knowledge and the context provided by the user. So it will make use of its own context. Now in this, it is like using the question, and then the context is the content which it has. So this is all the content. Now using this content, it is able to respond. So that is the, now here if you see, this will give the main features with more details, specific details of, like for example, you saw the rewards, right? So that is how you can actually augment your agent with real data information and also bring in the conversational aspect to it. So the other flavor I'll just quickly touch upon, the call RAG chat. So if you don't want to expose your RAG agent, but you still want to use the, or you want to make the RAG facility available to other agents on demand, or like based on the configuration. So that is where we can use this functionality of, so here we have implemented using the call RAG chat. So basically this is like a kind of modularization of the content retrieval, and then it is providing it to the other agents. If they need it, they can just call this function by passing the message, and any, like this is by default top 3, so it will give you the response basically. And then it is augmented by defining it as a function. So if you are aware of function calling of this OpenAI, so you define a function which has an output of message type, and this is like just to control your output format, and then you provide this. So once you set this up, now you, so this LLM config is actually now the config which is augmented by the data, and that function is this function which you defined here. So it's like you brought the function outside and you're providing it as a plugin to your agents instead of, so it's kind of a reuse, you can say. That same like plugin or same function you can use for multiple agents by defining this approach. So here you can see that now the agents, so these two agents, the insurance agent and the like program manager. So these agents were like dummy agents without any RAG. But then now we have updated the config with the new config information. So now they have access to this RAG by making use of this function. So now if there is a group chat with all these, so in this case also, they will be able to make use of the RAG and then give the response. So yeah, just here, yeah, the last example here. So you can see that it is using the like the information and then giving the answers for the Cigna health insurance policy. So that is how we can augment the agent capability by your real data, by online tools, by APIs, external APIs, by bringing in this function approach. So you can have a function you can attach to your agent, and then your agent behavior is augmented with that. So yeah, with this, I would like to hand it over back to Scott to conclude this session.
Okay, thank you, Abhilasha. Let me see. Oops. Sorry, I was at the wrong slide, obviously. So, okay, thank you. So I just want to just take a quick pause to say thank everyone for joining. I know your time is precious, so I know we went just a little over. So I appreciate your time, but thank you for sticking with us. And just to kind of wrap up today, right, kind of some of the key takeaways. We've discussed what autonomous agents are and kind of what they can do for you, an example of those agents and kind of how they're architected, how we go about strategizing for how we're going to implement those, and as well as just kind of looking at an overview of humanistically how does an agent work. And then of course Abhilasha took a deep dive into the architecture of an agent and took us through a little demo of the agent using different scenarios. So again, thank you for joining for this session. And just to let you know, we'll be diving deeper into different areas of autonomous agents. So in the coming months, you can kind of look out for these topics like comprehending the agent implementation ecosystem for informed decision-making. So then exploring the evaluation landscape and agents or agent performance. And then also the developing agents tailored to specific domains and tasks to enhance business automation. So the other thing is we'll have the recording for you, so you'll have all this information for you, as well as the slides, I'm assuming, as well. So thank you again. And with that, Tanishka, I'll turn it over to you.
Yeah. So before we wrap up, I can see that there are a few questions in the question and answer section. So first question is asked by Sam. He wants to know, how does RAG with large language models address challenges or limitations in interaction between autonomous agents?
Yeah, so basically, if you're augmenting your agent with RAG, you're controlling the hallucination because you're giving a limited context. You can instruct your model to use only that context to respond. So that is one major limitation which you can avoid with the use of RAG. Also, with advanced RAG techniques, you can improve the relevance of your answer. So with these flavors, you can definitely improve the behavior of your autonomous agents.
Next up, we have a question by Alex. Alex wants to know, how do you think RAG and LLMs will contribute to the evolution of autonomous technologies in near future?
Yeah, so again, somewhat overlapping. We already know that LLMs are capable of producing really good content when given the right context and given the right prompts. So that context and prompt is what you can bring in with the flavor of RAG and the flavor of agents. So with these three things put together, you can actually bring in a lot of automation in the mundane activities wherein there is not major complex decision making involved. It is the usual rule-based behavior where a human being, a human, has to take decision based on certain conditions. So definitely agents can replace those scenarios unless there's a real human skill set involved wherein you cannot replace it. It's like maybe some special skill set. Again, I think Alok will disagree that we really want to go to that zero human intervention, and it should be like a seamless autonomous future. But then definitely with this ecosystem in place, we are on that track, and we will surely see much more powerful agents in the future.
So that is it. Thank you to all the speakers for sharing your invaluable insights, and a heartfelt thank you to each one of you for being a part of this webinar today. I trust that you found today's session enlightening. Before we conclude, I'd like to announce that we have an upcoming webinar scheduled for 14th of December. The discussion will center around implementing multi-factor authentication, that is MFA, with Keycloak. Do look out for your invitations in the inbox. Until next time, everyone, thank you once again for your active participation in the webinar today.
Yeah. Thank you, everyone.
Thank you.